Okay, so this is week 4, Tuesday, and we are going to go over the study guide for ratios for math 6. All right, so it says right here, can you compare two quantities using a ratio? Can you write a proportion that shows two ratios are equal? Tom rides 16 miles in 10 minutes. Roger rides 4 miles in 2.5 minutes. It says write a ratio that compares Tom's distance to the time Tom rides. Tom, distance, Tom. So this is just Tom, yes? So distance is right here. Distance is 16 miles. Time is the other one. This is time, okay? So then we're going to do, for A, your first ratio is just going to be Tom's distance over Tom's time. So distance is 16 miles. Time is 10 minutes. But you have to reduce this, right? Since both are even, you can divide it by 2, which then gives you an 8/5 miles over minutes. And that should be your answer, okay? So A doesn't ask you about anything about Roger. Do you see how this one has no Roger? It doesn't ask you anything about Roger, so you don't need that. Okay? All right, so next one for B. The ratio of Roger's distance to his time is the same as Tom's. The ratio of Roger's distance is the same as Tom's, okay? So distance, same. Write a proportion and show the two ratios are equal. So this is going to be Roger's distance. So Roger's distance over Roger's time. Roger's distance is 4 miles, right? And his time is 2.5 minutes. Because 2.5 is the same thing as 2.5, right? The good thing about this is both of these are in minutes, like the units are the same, minutes and minutes, miles to miles, right? Because if it wasn't the same distance, you would have to convert it to the same unit, okay? All right, write a proportion shows that the two ratios are equal, so Roger's distance is the same as Tom's. This is Tom's. Tom's distance over Tom's time. Tom's distance is 16 miles, right? Over 10 minutes, right? Now, the ratio is a factor. So when it says the ratio, it's going to be a factor of timing by some number, okay? To get from 4 to 16, 4 times 1 gives you 16. 4 times 4, right? 2.5 times 4, you see the ratio right here? This is your ratio, the times 4, okay? 2.5 times 4 also gives you 10. Do you see that? This is what you show. You got to write that down, okay? Okay, let's move on to number 2. Number 2, it says, can you find a unit rate from the ratio relationship? A fire hose can pump 192 gallons of water. So that's your first one, gallons of water. And here's your time, right? This is how much water. This is time in seconds, right? How many gallons does the hose pump out in 1 second? So how many gallons? This is going to be your X, okay? How many gallons will the hose pump out in 12 seconds? So there's actually 2 questions. This is A, and this is B. Do you see that? Okay, so there are 2 questions. So let's do A first, okay? This is A. First thing we want to do is we want to write down what the 2 fractions are in relations to. First one is gallons of water over time in seconds, right? First one's given to you is 192 or 19.2 gallons over 4 seconds, right? Equals A. This is part A. Do you see this right here? A asks you how much water does a pump out in 1 second. That 1 goes on the bottom, x goes on top, okay? Sure, Emma. You're going to cross multiply. So 192 or 19.2 times 1 is 19.2. 4 times x is 4x. When you divide it by 4 on both sides, you got to show the work. 19.2 divided by 4. So remember in fifth grade when you guys are doing dividing by decimals, so what we're going to do here is 4 times 4, 16. Oh, and you know what? I forgot. Hold on a second. You know how you have the decimal here? You're going to move it to the right side. So you move it to the right side. So it's 40 divided by 192. So 192 divided by 40. Okay. 40 times, so you're going to do this on the side. 40 times 4 is 160. So put 4, 160, 32. Then put a dot, put a 0. Well, guess what? 4 times 8 is 32. There's a 0. So then it gives you a remainder of 0. So then x here is x equals 4.8 seconds. So if you were to go ahead and respond to this question, I like to do it with writing. So I would go back to this. Oops. And I would say, the question asks you, how many gallons does a hose pump? The hose pump out, or it's not second, sorry, it's 4.8 gallons, right? Pumps out 4.8 gallons of water in 1 second. So that's your response for part A. Okay. Okay. So then let's go ahead and take a look at part B. Okay. Part B says how many gallons would a hose pump out in 12 seconds? Okay. So then here we're going to use the same thing. 19.2 over 4 equals 12 seconds. X is going to be on top, right? If you're just doing this as an estimate, Grayson, sometimes it's important to do that. Remember, 19.2 over 4 seconds, right? That's similar to saying, okay, 20 gallons over 4 seconds, right? 20 divided by 4 is 5. Do you agree with that? So it's about 5 gallons of water for every 1 second, right? So this is 1 second, then my answer will be 5. And is your answer similar to 5? 4.8 is pretty close to 5, right? So that's a good estimate, okay? So we're just going to do estimate, okay? Because this way you can check your answers. Now, on the other hand, if it's saying it's 12 seconds, well, it's just 12 times 5, right? So your answer should be around how much? 60 gallons. Do you see that? Yeah. Okay. So it's good to have that estimate so you can check your work. So let's go and actually find out the actual answer. So here you get 4x equals, now you're going to do this on the side, 19.2 times 12. 418 to 3 2 9 1. When you add it, you should get a 4 13 2 1 decimal. Oh, that doesn't, oh no, it does look right because I haven't divided yet. So 230.4, right? Now I have to divide that. So 230.4 divided by 4. Now watch this. You got to move that decimal to the right, which means you get a 0, right? So let's rewrite this. 2304 divided by 40. 40 times, well, 4 times what is close to 23. I will say 4 times 5, which gives me 200. 30, bring down the 4. 40 times 7 is 280, right? So when I subtract it, I'm going to get a 16. Now, if I put a 0 there, remember you got to put a decimal on top, and it's perfect because 4 times 4 is 160. Like 40 times 4 is 160, right? Which then give you a decimal of 0 or a remainder of 0. So x equals 57.4. Is this gallon or is this second? So the question asks you, how many gallons is a pump? 57.4. And that's a pretty good estimate because didn't we say it's about 60 gallons when we did the estimation here? So then if we're going to go ahead and type this up, you could say, and this is for B, the hose pumps out 57.4 gallons of water in 12 seconds. Does that make sense? Okay, let's go ahead and do question number 3. Your heart beats 80 times a minute. How many beats per minute is this? Okay, how many beats per minute? Per minute implies, or per second, implies 1 second, okay? So your ratio, or not ratio, your proportion is relationship. So proportion, relationship is going to be heartbeat over minute, right? It is going to be 80 times 1 minute. Well, there's 60 seconds to 1 minute, right? Do you agree with that? Since your answer wants second, I'll do 80 beats. Instead of doing 1 minute, I'm going to write 60 seconds instead. Do you see that? The 0 cancels, so I have 8 over 6. Reduce it, 4 over 3. This is still 3 seconds. The question asks you for 1 second, okay? And it's asking you 1 second equals how many heartbeats. So what do? 4 divided by 3. Put a dot, 0. 3 is 9. 0, 3. So it's going to say, it's going to be approximately, oops. So go back to your question. How many beats per second is this? You can write the heart beats 1.33 for every second. And you just go back to the last part of the question and answer it. Does that make sense? Okay, let's move on to number 4. Can you find a scale factor to relate two similar figures? Can you use a scale factor to solve proportion situations? On a Lego model of the Statue of Liberty, 3-inch segments. You can go, baby. Represents 15 feet. So this is going to be your proportion. Your proportion is going to be inches of Lego, right? Bottom is going to be feet of Statue of Liberty. Okay, so 1 inch on a Lego is going to equal to the number of feet of the actual statue. Okay, so it says on a Lego model, 3 inches on the small little toy represents 15 feet on the actual statue, right? This is your, what did I call it before? Proportional relations? What was the term that your teacher used? I forgot the actual term. Hold on, I know I have it here somewhere. Do you remember the language that she used for the proportion? It was like, hold on. I think it was just called proportion, maybe. I should use a different way. Proportion. Oh, ratio relationship. That's the word she used. Okay. So the ratio relationship. So ratio relationship, right? Okay. Equals, find the scale factor. Well, your scale factor is going to be inches of Lego, which is 3" over 15 feet. Now, make sure you reduce that so it's 1" over 5 feet. This 1" is the measurement. 1" is going to be the measurement of the Lego, okay? Of Lego in inches, right? Denominator is the actual measurement of the Statue of Liberty in feet. So 1" on a Lego equals 5 feet of the actual Statue of Liberty. Does that make sense? Okay, so in answering the question, which asks you what is the scale factor? Scale factor equals 1" of the Lego equals 5 feet of the actual statue. And that's your answer. Are you okay with that? Okay. All right, let's go on to number 5. Can you recognize proportion relationships? Can you create a table showing equivalent ratios? Graph coordinate relationship on a coordinate plane and interpret a point in terms of a situation. Harold's Sandwich Shop sells their sandwiches by the foot. 3-foot sandwich costs $8.25, right? So a 3-foot sandwich costs $8.25. If I want 1 foot of a sandwich to see how much it costs, it would be $8.25 divided by 3. Do you see that? Okay. Well, a 7-foot sandwich costs. So what we can do with this is you have the price of the sandwich over foot, right? It gives you $8.25 for 3 feet, or you could do a $19.25 for 7 feet, right? Complete the table to show the proportion, okay? So then what you can do is you can go ahead and just use this proportion here, the 3 with the $8.25, okay? So let's do that. It asks you for 1 foot. So let's do this. $8.25 for 3 feet. 1 feet, X is price, right? So 3X equals $8.25. Divided by that, let's work it on the side. 8.25 divided by 3. You move the decimal over. So you have 825 divided by 300, right? 3 times 2 is going to give you 600. So 225. Put a dot, put a 0. Now, 300 times what is close to 2250. I will say 3 times 7, because that gives you 2100, right? Subtract it, it gives you a 150. Put a 0 there, you put a 0 down. 300 times 5 will give you that. So your answer here really is $2.70. But just to make sure that this is correct, I'm going to go ahead and use a calculator to make sure that this is accurate. And what were we dividing again? What was it? 8.25 divided by 3. 2.75. Oh, here we go. I don't need to put a 0 there. So there we go. There's your answer. So 1 foot is going to be $2.75. Okay? Do you see that? 2 feet. For 2 feet, we're going to do the same thing. For 2 feet, it is going to be $8.25 over for 3 feet. 2 goes here, x goes on top. 3x equals, when you cross multiply, 8.25 times 2 is going to be $16.50, right? Then when you divide it, 1650 divided by 3, and I want you to actually show this when you do it, is $5.50. So that'll be $5.50. Do you see that? Okay. So what you can do is, okay, 1 foot is $2.75, right? Because this right here is a lot of work. Do you agree? If 1 foot equals $2.75, for 2 feet, can we just do $2.75 for 1 foot times 2? Let's see. That'll give you a 10, 14, 15, 4, 5. Did it give you the same answer, Grayson? Did it give you the same answer? Yeah, it gave the same answer. 3 feet is $8.75. So for 7 feet, could we just do $2.75 per foot times 7? Yeah, that'll be a lot easier. Or you could cross multiply and do it that way, but it takes too long. 35, 49, 52, 14. So that'll be $19.25. And that's good because so far everything looks reasonable. Now the cost of sandwich is $11. So how many feet would that be? You just take $11 and divide it by $2.75. Do you see that? Okay. So here you move 2 to the right, 2 to the right. So then you have, hey, Grace, Emma, stop. 275, like that. You're going to have to go ahead and just divide it. I can say that if I do 275 times 3, 21, 22, 6, 7, 8, that'll be 825. I think I do 275. Let's see what we get times 4. 20, 28, 38, 9, 10, 11. Oh, actually, that's perfect. Times 4. 275 times 4 is 1,100. So 4 feet. Does that make sense? Okay, so that's what you have. Question 5. Find the point 6, 16.5 on your graph. So here we go. Do you see this part is feet of sandwich? This is cost, right? 6 is going to be x because that's foot of sandwich, right? 16.50 is y. That's going to be the price, okay? So 16.50 is going to be right here. Actually, that's 17, right here. Do you see that? Explain what it represents in terms of the problem situation. So what this means is 6 is the x value, which is foot of sandwich, right? 16.50 is the y value, which is the cost of the sandwich. Okay. 6, 16.50 means a 6-foot sandwich costs what? $16.50. Explain why this represents a proportional relationship. Each foot of sandwich costs an additional $2.75. To find any foot of sandwich, take the foot of sandwich and multiply by what? $2.75. Because I might want 100-foot sandwich. You know what I mean? In which you just take 100 times 2.75. Is that it, basically? She didn't want you to graph anything else here?
No, there's no backside.
Well, no, she didn't want you to graph the rest of this. So this right here, I'm just gonna go back to this, represents 6, 1650, right? But if I were to graph everything else on here, like all these other ones are also points as well, like 1, 2.75 is right there, okay? 2, 5.50 is right there. 3, 8.25 is right there. 7, 19 point whatever is right there, right? And then 4, 11. Do you see that? This represents a linear line right here. Do you see how when you complete it, it represents something linear? So if I was like, I want to buy 2,500 feet of sandwiches, you just keep going on that line. It should tell you how much it costs. Okay. All right, that concludes it. All right, I gotta